There are one important question: wide and narrow transformation. What is the difference between the wide and narrow transformation? So, narrow transformation is nothing. One to one mapping. One to one mapping. And wide transformation, one to many mapping. Between RDD partition. Narrow transformation one to one mapping between RDD partition, and wide transformation one to many mapping between RDD partition. Or data frame partition is nothing. So wide transformation is the more so I will give you one example for narrow. I will explain one by one everything. Narrow transformation, map, flat map, filter, union, Coalesce, and repartition. These are the example of narrow partition. Now, what is the wide transformation? Wide transformation, reduce by key, group by key, join. These are the wide transformation, right? Now, other is the distinct also, we can say. This is a part of wide transformation. Co-group, if you are using co-group function, this is a part of wide transformation. So narrow transformation is a type of transformation where each input partition, basically, what is the narrow partition? Narrow transformation is a type of transformation where each input, I will define you, then I explain. Partition contribute to only one output partition. What is the meaning? If you can see this example, I think when you can see the images picture, it will be give you the more clarity. So narrow transformation, each input partition participate only one output partition, right? Map and filter is the each the transformation based on the partition wise, not, it is not a contribution and another partition for this single partition. So if you can see, map, filter, join with input co-partition, union also, if you can see union also, only one partition perform on the narrow transformation is a type of transformation where each input partition contribute only output partition, right? One output partition. So if you can see the contribution is the one output partition. If you can see that one map is perform the another one partition map perform the transformation only one partition and giving the one output, right? So these are less shuffling. So what we understood by map and filter, this is a less shuffling. Join with input co-partition. Also, this is a part of the narrow dependencies, right? And clear or not clear? What is the meaning co-partition? There is the one term. If you can see, what is the meaning of co-partition? Only one output partition, right? So it does not require what we understand from this picture does not require more sampling. Co-partition. These are two partition. We partition based on the join, right? These are first table and two table, and they are separate out, right? Join with the input co-partition, like a union. Join with the input co-partition, similar like to union, right? So narrow transformation it does not require data shuffling alone or movement across the partition. So in simple word, what we can say, narrow transformation, narrow transformation are executed within a single stage without requiring data exchange between nodes. So are executed within a single node without requiring data exchange between the nodes. So they are not exchange any data between the nodes. So I will give you a few example map. If you can see union, so we don't need to what happened in the different trans. It will be create a new stage with the same one, new partition, right? It will be create a new partition with the same like map filter, right? So I will give you a few examples. In more simpler word, we can say narrow transformation are operation that can be performed on a single partition of data frame. Agree? Narrow transformation are operation that can be performed on a single partition of data frame without needing to shuffle the data across multiple partition. Agree? You understood this point? So narrow transformation perform a single partition data frame without needing the shuffling because there is no shuffling. If you can see, there is no shuffling the data in the narrow transformation. These okay. What is the benefit of this transformation? So these type of transform often faster. Definitely, there is no shuffling. So across They're more faster, more efficient than wide transformation. We know that wide transformation has a more shuffling. They can execute the parallel in each partition. Because why they are more faster than it? Because they can execute the parallel each partition. It can't be interfere the different partition. Don't need to shuffle the data, because data shuffling will be a input output overhead issue. So it will be slow, right? So I will give you some example, like more example. Narrow transformation are operations that can be performed on a single partition of a data frame without needing to shuffle data across the partition. We already discussed this one. Now we can see, we have seen map, flat map, filter, flat map, union, join with input co-partition. They are doing a single partition. We don't need to create a data shuffling, right? Now, count the return or number of the data frame. The operation can be done a narrow transform because it required counting the row in each partition and summing the result. So what happened? uh, Driver node aggregate the all the result. So each partition give you the count and send to the data frame, and it aggregate the count, right? So there is no data shuffling the count. Return the first of data frame. This is also narrow transfer because it require return only first row of the each partition or selecting the minimum value. So we are not shuffling anything, right? We are selecting the minimum value. Takes the n rows of the partition, first n rows of the data frame. Same thing. This operation can be done a narrow transformation because it only requires selecting first row, n row of each partition and concatenating the result for each. Apply a function each row of data frame. This operation can be done as a narrow transformation because it only requires applying the function each row, each partition. Reduce, apply the function to reduce the row data frame to single value. This operation can be done as a narrow transformation if the function is associative and commutative, which allow the computation to be performed in parallel on each partition, then combine the across partitions. All right. So this is an example of narrow transformation. I'm doing a map. Just I need to create a cluster. White transformation. White transformation is a type of transformation. Okay, it ran 1 minute before I can see you. You can see here. Stays. One stage you have been completed. Only one stage. We don't. If there is a shuffling, the new stage will be created. But there is no stage will be created because there is no partition. Because is the if there is a shuffling of the data, new partition will be created. But first we are taking an input, then we perform only map aggregation, like multiply by 2. So basically there is, so you can see that this is called this is called map partition, means this is called the uh, RDD, map values. So narrow transformation. Each input, each partition contribute only one partition. What is the wide transformation? A wide transformation is a type of transformation where each input partition can be contribute the multiple output partition. It involves shuffling and data movement across partition. The resulting stage boundary often resulting in a stage boundary spark. Wide transformation require coordination and data exchange across the nodes. Basically, this is a basic definition, but you can see group by based on the key group by and reduce by key. I will explain in the my next section what is the difference between group by and reduce by key. So group by and reduce by key is the grouping the data first, then aggregating, right? Grouping the data first, then aggregating, and then perform the this one. Then perform the output. This is called group by and aggregate by key. This is wide transformation. So I will give you one key, reduce by key, group by key, or join. So if you can see here, stage one, two stages has created here. If you can see stage one, stage two, because reduce by key, if you can stage this one, the shuffle RDD, map partition, that shuffle RDD, unordered partition by. So basically, it's the wide is the transformation. There is the multiple partition data, multi input data, one input data, multiple input data participate to contribute for output partition. What I explain here. So I think this is one of the important question. So each input partition can be contributed to multiple output partition. I think this is a very important.